Now that we have our runtime dependency, the annotation processor, and then KSP, touching the Kotlin and the Java, and we're going to straight away make a brand new file that's going to represent the structure for a single task item, our tasks table or our tasks collection. So right-clicking on the main package, we will put everything in one folder for now, but later on we will look to reorganize the files and put them in better packages. So a new Kotlin file, we'll make it a data class, and we'll call it simply a task, a data class called task. Now, if you've performed a Gradle sync and everything was working okay from the previous tutorial, then you should have access to a brand new annotation. So we'll do @ and then ENT, and then you can see there AndroidX.room entity. That's what we want, autocomplete. So thinking about SQL and databases, and we have collections of data, a collection would be a table, a student table, a product table, or in the case of our app, a task table, a table where all of the data we need for each task is stored as a collection. And that's what entity means in Room, a single type of data that will be gathered together. So by annotating @entity, we are effectively creating a table, a collection. And this annotation, later on when we create our database and build for the first time, is going to convert this very simple data class into quite a bit of automatic SQL code. And we're going to be able to click into that generated code and see what is made and see how it directly relates to SQL and the create table command. So thinking about the things we might need for our task, well, maybe the title of the task, and that shouldn't be null. We must always have at least a title. But then perhaps we have a description. So VAL, description, also a string, but that could be null. And maybe it defaults to null. So it's possible to make a task object just with a title. And then we might have a Boolean value for whether or not that is a starred task. So VAL is starred of type Boolean. And again, by default, that could be false. It's also going to be useful to us to have an ID in case there's two tasks with the same title. So at the very top, just by convention, it's nice to put the IDs at the top. We'll do a task ID. We'll make this an int in Kotlin, and we can do the second of our annotations to mark this as a primary key. So @pri, @primary key, and this simple annotation on this property will do all that's needed to convert this column, when the task table is created, into a primary key. However, we want to go one step further, and we want to make sure that this will increment automatically. So after the primary key, we do some brackets, and we can do a property called auto-generate. You can auto-complete that to auto-generate equals true. So this will mark the task ID as a primary key, which will enforce it needing to be unique. You can't have the same primary key twice in one table. But adding auto-generate equals true, that's what we need to have it generated automatically. And to make sure that when we create a new task object in Kotlin code, if you do equals 0, I can just do a bit of fake code underneath. I'll do a little test function here just to show you. So you can make a new task object now, and you don't need to provide a primary key. In fact, we can just provide a title of our task, and we'll get onto this syntax in a moment of actually naming your arguments, okay? But you can see there's no errors there. We have a default value of null for description, a default value of false for is starred, and we have a default value of 0. But when it comes to us inserting our task, because we have primary key auto-generate equals true, well, 0 is not a valid number for an ID, so it will go ahead and give us the first available number automatically. But that is all we need to write for defining a table in Android Room. And how much easier is that than all of those complicated create table SQL commands? A data class is what we know in Kotlin. It's what we're in Android Room. And how much easier is that than all of those complicated create table SQL commands? A data class is what we know in Kotlin. It's what we're comfortable with. It will make the column names exactly as we have them here. So task ID description is starred. It's not in that snake case that we like. And in Kotlin, if you hover over that, it doesn't like underscores. Underscores aren't really a Kotlin thing. So if you wanted to have a different column name to what we have here, and it doesn't matter, well, you can do another annotation for column info, and then brackets, and then you type name equals whatever you want. Now this one for title is pointless because it will automatically be written as title, so I can delete that one, and I can paste it into is starred, and this could be is starred. So these annotations give us the flexibility to rename columns if we don't like that name. So we could have another annotation for our primary key, and that could be task underscore ID. Okay. I think I'll go ahead and leave the column infos. It doesn't really matter using camel case rather than snake case. It's not going to affect things in SQLite, and it makes our code smaller and simpler. But with this code here, we've defined our first table. In the next tutorial, we will write the small bit of code to set up our database and provide this entity, this task table to it. And then when we run the project for the first time, I'm back on the Room documentation, ready to find out how to make our database. I didn't refer to the documentation in the previous video, as hopefully you can see with an entity, defining a collection, defining a table, there's not too much to it. You mark it as an entity with that annotation. You can choose a primary key. We covered auto-generate for the key. This doesn't have that. You have to go into a bit more detail in the documentation to see that. But we also introduced the idea that you can rename your columns if you want using column info. It's really not too much code. I'm going to skip past the data access object for now, and we'll jump straight to the small amount of code needed to create a database. We can see here an abstract class called whatever we want that extends a Room database. We're going to ignore the DAO. In fact, we don't even need that line at all, but we do need the @database annotation. The Room compiler, the Kotlin symbol processor, will take this and the underlying code, and it will know what to do to write the SQL to create our database. So let's copy all of this for now. So @database and back to Android Studio. And we'll copy this code in a separate file to our task entity. We'll keep our code nicely separated. So right click, new file. We'll call this the get it done database. Make it a file just for now. Empty file. Then we can paste that code. And I'm going to rename @database to our own name. This can be the get it done database. And then I'm going to go ahead and import these things. So I'll import the Room database first. Alt Enter. I'll import the @database annotation. And then we don't have a user class, we have a task class. And we can delete the DAO for now. And as you can see, the database is currently grayed out, it's not used, but we've got two things here. We've got something that we've marked as an entity, our task collection, our task table, and we've got our database, which we give two things to. Entities equals, and then an array of all of our tables. We only have one now. You could separate these by comma if you had more tables. Some other class. Okay, that's where you would put all the tables that you have, all the entities that you've defined. And then a version, because every time we make any change to the structure of the database, changing a column, changing a name, adding a new table, removing a table, you need to have a new version. And we'll talk all about migrations from one version to another when we come to it. But that is all the code that we need. If I go ahead and run this now, compile this, build this code, let's see what happens. Okay, I'm not going to show the emulator on the screen. The things we're interested in here aren't within the app, they're within the code, and more specifically the generated code. The first thing you may have noticed is that the Get It Done database is no longer grey. It's being used or referenced somewhere. And where might that be? Well, looking in the project pane, for the first time now, we're going to head into the orange build folder. Orange folders tend to be things that are automatically generated by Android Studio, and generally speaking, you shouldn't touch them. But we're now very interested to see what is the generated code. What have these small, simple annotations done? And when we've compiled this, when we've built this, what has been the generated code? So within the app folder, there is a orange build folder. If you open this up, there's another folder called generated. It is the generated code we're interested in. So we'll open up generated, and then we see there is a folder for KSP, our Kotlin symbol processor. That's the overriding thing that generates the code. Let's open up KSP. We have debug, then we have Java and Kotlin. So let's open up Java. And then we have the same package structure we have in our source folder, so java com.vinnorman.getItDone. You can see that kind of mirrors what we have here, java getItDone, okay. But we have this strange new file called getItDoneDatabase_impl, and that's short for implementation. We made an abstract class, we gave it an annotation, and the clever Android Room library will implement some actual code based off this simple bit of information it has here. So let's head inside and see what it's made. And if we scroll down, goodness gracious me, we have lots and lots of generated code there. You'll see at the very top we have this support SQLite open helper. And let me tell you, for those of us unlucky enough to have been working with Android for many years, before the Android Room library came about, we had to use this. All of these database db.exec and SQL commands, we had to write these ourselves from scratch. But look what Android Room can do for us. If we go to the create all tables command, which will run when the database is first opened, then we have some SQL that is executed. Create table if not exists, task, primary key, not null, text, integer. Hopefully this is quite familiar. Let's go one step further. Let's close the project pane. Let's get our original task entity here. We'll right click and do split right. So we'll have our task on the right, our task entity. We'll go back to this getItDoneDatabase implementation on the left. And we are allowed to play with this code even though we really shouldn't. I will do some line breaks, specifically around the create table command. And then I'll put the SQL command on a new line. So create table if not exists task. And then I'll do it like that. Create table SQL created for us. Create table, it says bracket, tab this foot. But then we have description created my is there we have. Create table if not exists, lowercase task, task ID. So by building again, the Room compiler has looked at our annotations and it knows what to do. And it's made all the changes that we've asked it to. Okay? So that is the whole point of the Room library. It takes complicated, cumbersome and lengthy things like this and converts it to something that we understand, a plain and simple data class, and these few annotations is all that the Android and Kotlin and Room compiler needs to convert what we know into the necessary SQL commands.